G'day guys. What is object-oriented programming, aka OOP, and how does it differ from regular programming or not object-oriented programming? This is a question that I got asked somewhat recently and I thought that I would answer it via a video. So OOP is a style of programming where you basically organize your code into objects, and the reason why you want to do that is that, generally speaking, organizing your code into objects makes your code a little bit easier to reason with, a little bit easier to think about mentally, and generally, or at least theoretically, a little easier to reuse as well. So there are basically four, you could say, pillars or main concepts when it comes to OOP. And if I go through all of them at once, this probably will turn into a rather long video. So I'm thinking I might go through these one at a time, starting with what I think is the easiest one, which is encapsulation. So to give you an example, since I know that the definition I gave earlier is kind of hard to understand without any example. Let's just imagine part of the code for the original Mario game. And we want to basically control the player. So what information might we have? By the way, I'm using C#, which is an object-oriented programming language. It's very easy and encouraged to write object-oriented code using C#. But even if you don't know C#, that's completely fine. I'm not going to smash the language too hard. I'm mainly just using it to highlight the main concepts, which are these. So even if you don't know it, so long as you know a programming language, be it JavaScript, Java, Python, whatever, the syntax might be a little bit different, but we're not going too deep into the C# syntax with this. So with that out of the way, let's get into our Mario game. What information do we need? Well, we might want something like the frame rate. You might want gravity. You might want, let's see, the number of enemies on the screen. And then we'd probably want some information about Mario as well. So we might want to have Mario's X coordinate, Mario's Y coordinate, let's say that's 80. We might want Mario's width. Let's say he's 25 pixels wide. His height, which let's say for example is 75. His color, which is red. And then we'd want some operations. So you can jump and you can move. And let's say that whenever you jump, we increase his Y coordinate by a certain amount. So let's say we say Mario Y plus equals 20, and then we print out the new Y coordinate, and then we set it back since you've descended. There's all sorts of problems with this, but just for illustration purposes, let's run with it. And for moving, we'll do a similar thing to his X. So we'll increase his X by 20, and then we'll write new X, Mario X. All right, and let's start off by jumping and then moving. And if I run this, we can see here we've got a new Y and a new X. So it seems to be working, but you can already kind of see, even at this level, it's starting to look a little messy. We've got stuff like the frame rate, gravity, and the number of enemies kind of getting mixed up with stuff that's to do with Mario. And it's very easy with this style of coding for something like the number of enemies to somehow indirectly affect, for example, the height of Mario. It's very easy for changing one variable and having it affect another down the line, especially once this balloons out and starts to get bigger. So one core concept of OOP, which we're looking at in this video, is encapsulation. So the idea here is we take all of the stuff to do with Mario and we encapsulate it into an object specifically for Mario. And the way that you do that generally in OOP is you create a class. And a class is like a blueprint for an object. So let's grab all of this stuff to do with Mario, and we're going to create a new class, call it Mario, and we're going to dump all of this stuff inside here. And what we then want to do is we want to create a new instance of Mario, and we want to call jump and move and have it behave exactly like it did before. So we'll create a new instance of Mario, and then we want to say Mario.jump and Mario.move. Since jump and move are methods, which are object-oriented terms for functions inside of a class. So you might call this a function. In OO language, you would call it a method. You might call these variables, but once they're part of a class, you would call them fields. Now, you'll notice that we've got this squiggly line here, and the error message that we're getting is that Mario.jump and Mario.move is inaccessible due to its protection level. And this is, you could say, another sub-concept of encapsulation. When you do this, when you move variables and functions into a class, you automatically get the ability to control the visibility of all of these different things. So by default, none of this stuff is actually visible outside of the class. So if you try to access the bits of information that are inside of Mario, and the way that you usually do this in an OO language is with a dot, there's not really much that you can get. This is all system default stuff that you get with every object. So none of that stuff that we added is actually visible. And that's because it's deeply encapsulated inside of Mario. None of it is being exposed. So whatever we want to expose, we need to do so explicitly. And we do that with a public access modifier. So if I add the word public before the type of the method, that makes it accessible outside of that class. And I'll do the same with move. But everything else I'll leave inside of Mario, and that way the functions are visible. But if I try to access like Mario X or Mario height or anything like that, it's completely not accessible. And if I run this, we can see we're getting the same output, but this time all of that other information is encapsulated inside of Mario. It's not visible outside of Mario. It can't be changed outside of Mario. So the way that we had this before, anywhere in the code could modify Mario X and Mario Y, and crazy stuff could happen. Whereas this way, because it's, to use that word again, encapsulated inside of Mario, the only thing that can modify Mario X and Mario Y is this instance of Mario. Now, another cool thing that we can do, not necessarily related to encapsulation, but just while we're here, is you can create multiple instances of a class. So when we had all of this in program.cs, which is kind of like the index or the main page in a C# program, it would have been rather difficult to create multiple copies of Mario. Whereas by putting it in a class, it's extremely easy. You can just create Mario2 is new Mario, and we can say Mario2.jump, Mario2.move, 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 and maybe Mario.move at the end. And I guess what I'm trying to highlight here is maybe I should have added like a name for these, but you can see that where are we? So original Mario is at position 70, and this is Mario 2. He starts at position 70, then position 90, and then position 110, and then at the end we've got Mario, which is moving to position 90. So each of them have their own XY coordinates. Each of them have their own copies of all of this information. So yeah, reusing classes, as we've done here, is very, very easy compared to doing it without classes. And I think that wraps up encapsulation. I'll post a link in the description to another video where in the same solution, using the same example, we'll talk about inheritance. See you soon.